This way. I'll need a copy. Okay. Okay, does anyone else still need to pick up their exam from last week? Yeah, what's your name? Again, the numbers posted on here are just the raw points, not the percentage. You'll need to look to the Moodle post for that, sir. Ashley, you did not reply to my emails asking if you would not be here today.
No, I did not. I forgot.
We need to have a discussion.
Okay.
Yeah, so we can make arrangements. There's very little time to do this. So, yeah, please contact me, and so we can have some email exchange later this morning.
Okay.
Okay, folks, it's about that time. We're going to do a laboratory activity, and we're going to have you work in groups of 3. And you've got a little worksheet to work through. And the way I'd like to do it is, let's see. I'd like 2 people on one table and 1 person on the next table. So let's see, you've got 2, 3, 3, 3, and yeah, actually, can we consolidate? Can I talk, Mr. Anderson and Mr. Hunter? Can I talk you to move it? So if one of you could sit over here, and the other sit over there on the end, we could have groups of 3. And so basically, you'll need to be working with the people on the table right behind you and right in front of you. So group of 3 with Mr. Anderson, you 3, you 3, and you 3
I
in
think
front.
we just got some more people coming.
1 person. Could you move, please? Or actually, did you just come in?
Yeah, I walked in.
Okay. So yeah, if I can, one of you move back over there to make a group of 3, and I'll have the other 2 up here. In fact, how much, sir, could you move it there? And I'll have the 2 of you work together.
Okay.
Mr. Anderson and Miss.
Jeez.
Yes.
Okay.
Okay. So all of you should have one of these little sheets, and it's fairly explanatory. I'm hoping that you might have had a chance to read through at least the first one. The plan is to have a shared chunk of equipment, and there's several investigations. I think we're going to go through 6 today, is my hope. And the plan is to have, for the first activity, everybody essentially have a light bulb and a wire. And then for the second activity, have one group, one person do all the equipment with the other two people convincing. And if the next experiment, hand that equipment to another person in the group. And so you always have one person actually only touching the stuff and doing this manipulations while two other people are, contributing, asking about stuff. Because it's, that just seems to make the most sense. And again, we're doing manipulatives today, so I encourage you to, certainly by the end of the class, if not a couple of times during class, use the hand sanitizers on things. Okay, so let's start off with the first activity. And for this, I want you to go ahead and read and put down your idea. So all of these have steps to them. In that you come up with your idea without touching anything. So hands off equipment, basically draw a picture, express your thoughts in like a paragraph or so, and then talk it over in your group with, see what other people are thinking in your group to kind of write down, consensus. I mean, it could be something simple as we all agree. Or if somebody has a different point of view on the next step, mention that. And then only on the third step, where it's making observations, you actually start playing with the equipment. So I'd encourage you to read the first step about how to make a light bulb light up with a battery. And then talk it over and then distribute it so everybody has one light bulb and one battery and one wire. So you'll have to take the batteries out of the battery holder for this. And also you'll have to take the light bulb out of the battery holders. And when you do that, be careful because some of these have a little piece of metal jammed in the bottom to give good electrical connection. So whatever you do when you unscrew the bulb, don't tip this thing over because some of them have a little piece of metal. This one doesn't. But some of them have a little piece of metal in there that could fall out. So just screw it out and just leave it horizontal. So go ahead, read, and then record your thoughts and then discuss them.
Okay, so I'm gonna go troubleshoot the other thing. And we tried this with a piece of wire that was closed. That it actually was just basically an unfolded paper clip, and the result we got from this was basically any configuration that had the wire connected going through the light bulb would create a short circuit, and it would just heat up the fire.
Okay, you didn't really write anything down, but you drew a picture.
I drew a picture.
That's probably good enough. Just as long as you had something down before you had a discussion.
And I don't think we can divide the wire.
No, you can't divide the wire. You gotta drive one line for the wire. You just have one wire.
Oh, okay.
You're only gonna allow one wire for the first
Then
question.
let me redo
Take a
my
moment to
picture.
reconfigure. No worries.
So just to be very, very clear, the first question is, how are you gonna make this light with just one wire, one battery, one bulb? That's the question.
I'm gonna go refill these batteries.
Oh, you're late.
Excuse me. There's only two in our group.
No? 3.
You're with us?
Yes, she's in your group.
Okay.
Go ahead and sit over there and join us. We'll just have a group of 4.
Yeah. Hi. I think we had a high level of a few things. And then just like, I think, that's what it's, yeah.
And once everybody has theirs,
Because
ready, we will.
to get it to light up, you'd have to have at least something in there. Full side. Like if, like you just stuck it to one end, it would light up if they were, you could actually, you know, I guess like simply like it comes through it to like a different side. So it either have to be connected or grounded.
So there needs to be wires on both sides of that.
Yeah, because if you, because you can't just like, I guess, throw electrons at it and just have them stay there.
Yeah, that makes sense to me. You had done this better with the wire and I connected it.
Okay. I'm sure you're.
Folks, once you're ready to actually do the experiment, wave your hands and I'll come over and check what you have on your pages. Again, once you've had some discussion, you want to write a short note on what other people's ideas are in your group.
See when we're starting this over 2 days.
Those two.
If anyone is through summarizing other people's ideas on your page, whoever's finishing first could probably dismantle the equipment and make sure that you have 1 battery per person, 1 wire per person, and 1 bulb out of its socket per person. And again, be careful not to turn the sockets upside down because some of them have a little metal piece inside that we put in for good contact. Those are the older ones, Braden. Are there many out here with that?
The white ceramic ones?
We've even had to do it with some of these black plastic ones,
Okay. Not that I'm aware of.
but I'm pretty sure all the white ones have had that.
There are some white ones. Not too many, but
Yeah, be especially careful with the white ceramic ones. Let's see, who is behind you? Okay. Nobody. If we have 1 more person come in, we'll have the 3 of you 2 and whoever's there work together. And I'll just have you 2 work together. And the final is to have a 3rd on a chair. if need be. Is anyone ready to do the observations?
One thing I noticed right away.
Okay, go ahead and distribute the toys.
We don't have enough.
Don't turn the sockets upside down, please.
I can speak.
Yeah.
We don't have enough lights over here for everybody to do stuff on.
We have some behind there.
So from there?
Yeah.
Okay.
Actually, one of them is, they're closer. And that means you would not be very close to them.
Okay. Just one.
Okay, I think we're ready, yeah?
Dr. Steve, is there anything that we should not
So-
do in a like process?
No, this is incredibly safe. You could actually pop the battery in your mouth and munch on it with fillings and it would not hurt you. You have to actually break the outer case and suck the acid for any damage to occur. So I would encourage you not to put the entire battery in your mouth and deliberately try to bite through the metal shell. Nothing short of that would cause serious harm. So however, I have clipped the alligator clip to my nose and full on occasion, and that is hurt.
Okay, so we're all ready. So.
Oh, don't put the alligator clip on your tongue either. Not only is that unsanitary, it also hurts. I would also avoid clipping your eyelids.
We're gonna get you another one.
Okay. So the configuration I have basically just has a light bulb attached to one of the ends of the battery, and then the wire connecting from the end of the light bulb to the other node on the battery. Does anybody have anything different from that?
So I encourage you to try all of the ideas that were posed by your group. And if you can't make any of those to work, just play around with it and see if you can get it to light. And then raise your hand if you can get it to light. I want to basically acknowledge whoever got it. Did you get it to light? Yay, he got it to light. Okay. Don't see what he's doing. Turn away. Test your ideas.
One thing I know about the light
You want to definitely make a comment as to whether or not your idea worked or did not work.
So.
And then you want to write a statement as to what do you think is going on with regards to the flow of electricity, which we have yet to define.
So I think for one of the group's ideas, we can basically just put, we all pretty much have the same idea except for one other, which we just proved for the.
Electricity heavy system, you use
I mean, if it lights up with like this, then that's you.
So we all pretty much have the same idea.
You shouldn't actually have to clip the alligator clip on the light bulb. It's not designed to do that. Basically use the tip of the alligator clip like it's a bare wire to touch the things. So this involves some dexterity. You'll have to hold three things with two hands.
All right, I think we're ready.
But you have multiple fingers.
I think we're ready to start the observation over here. Okay. Who's set?
Even that is working.
You both need a light bulb. All right. Wait a minute.
No, I couldn't. No metal attachment.
Yeah.
I tried to run both of them.
You got it.
It's not lighting up for the board. There's no way to actually do both sides at the same time.
That's what I was thinking, is if there's an actual place for them to flow, like through the light bulb, it's not gonna light up.
Can we move on? Thank you, Connor.
At least that's my thought.
No, don't move on after this activity. Stay on E1 for a while. But be sure to, for each question, write something down.
Like this is fine.
Yeah, so record your observations, make a comment on making sense. And then on page 4, there's question 5.
So,
Because there's basically, just to be clear, there's another discussion period. So you want to put down your ideas for number 5 and then have a group discussion. But
okay.
you could
so
do all
four
at
is
pretty much the same time.
So 4 is individual and then 5 is discussion.
And 6. After completing question 4, raise your hand if you've not been able to get the bulb to light.
Say what?
What I did for mine was, I set it on the one end of the alligator clip. Use one finger to hold it to this tip and then just use my other finger to hold it together like this. You could probably also set the battery on the end of the light and get the same result.
I tried it.
Down the receipt, stay stronger. Yeah, I did that and it worked too.
Okay, how about a quick poll? What group has not been able to get a light bulb to light? This group and that group? And, okay, yeah, that group. So 3 groups, okay?
And now just tap it and hold it to the tip of the battery.
Okay, could I get a volunteer to basically stand up and demonstrate how to light the light bulb with 1 wire and 1 battery? How about you, sir, on the end?
If I'm doing right here.
Yeah. Could you stand up? Okay, everybody, please give Mr. B your attention. I'm calling you that because that's the letter on your pad. What's your name, sir?
Dylan Bird. Okay, so connected one end of the battery, or one end of the bulb to the negative side of the battery. Using the 2 ends of the clip, 1 to the positive end of the battery, and 1 to the other end of the light.
Could you hold it up possibly for people to
Yeah.
see or? You should not have the holder, the battery, the light bulb holder. You shouldn't need that.
Oh.
You need to have the bulb outside. So you said you had
Yeah.
what's going on?
So I have the battery connected like the positive end.
Okay, wire to the, you have a wire to the positive end?
No, so the battery itself to the positive end.
I'm sorry, that's kind of contradictory. You've got a bulb and you've got a battery.
Oh wait, yeah, I'm at the bulb to the positive end.
Okay, how do you have it touching?
I'm just holding it currently,
Okay, what part of the bulb is touching the battery?
the bottom piece there.
Okay. So you've got the. Got that. And then where's the wire go?
And then the wire is going to touch the negative end as well as the battery at the same time.
The negative end of the battery and what other part of the battery?
The bulb itself,
Okay, so it touches the bulb. Where does it touch the bulb?
on the metal casing.
Okay, on the metal casing on the side. Okay, and was it Mr. Drury?
Yeah,
Okay.
so must be, I did it, I originally had it plugged in, so that might be part of my issue.
Okay, does somebody have, and this will work, does somebody have another way to light the bulb besides this way? Has anyone else found another way? Mr. Hunter?
Just with the battery flip.
Ha, the battery flipped. So. And so you had the bulb. Like that?
Yep.
Yes, both of these should work. So I'd like everybody now to complete this section by filling out sections 5 and 6. So let's see if I'm dexterous enough to do this. Ah, yes, I see it lit. Okay, let's turn the battery around, try it that way. And this takes a lot of dexterity. Ha! It is lit. Not very bright, but this works too. What you're doing is you're forming what's called an electric circuit. In order for electricity to flow in something like this, there has to be what we call a circuit. And the purpose of this exercise is trying to get you a physical feel for what that circuit is and to see if you can describe that accurately. And please do have some discussion, doesn't have to be very lengthy, with the colleagues in the group for question 6 on this activity. I'd like to move on to the next activity in just a minute or two. So nobody's at 132,
I
huh?
think we can safely.
No.
We've got a bunch of folks that have not participated. I know that Sierra was not going, and Sierra and Jacob aren't,
That obviously doesn't make them all light.
but
The only other person.
And
on
I also
is
went ahead and didn't think
Yeah,
you had.
she did not
one
thought
where
that
the
big.
light bulb was just attached.
the plan is to
And
have
that didn't work. at
people
first,
borrow
so
equipment and do this
we
outside
all
of class
agreed
in Zoom
that
session next
I
week,
completely broke the bulb in a
because
particle.
we didn't have enough setups for, because I want each person, if they're doing it remotely, to have their own batteries, packs, and bulbs. So Ashley, Jacob, what makes the most sense is for you to, unless you really want to sign off, because partly you're getting the answers to the questions that I'll be having you address when you're able to do this remotely next week.
All right, thanks.
Oh, contact. Conditions. Get up.
Yeah, so like, this is-
Okay, folks, I'd like to move on to the next activity, which is not E2, but it's going to be E3. E2 is going to be a take-home experiment. I'd like you to ponder this question over the weekend and write a paragraph, and I'll have a place on the Moodle site for you to, I'll probably do it as a quiz for you to enter your thoughts after you've played around with a flashlight. Think of that as like a homework assignment. So I'd like you to polish up what you have on activity E1-1 and then switch to E1-3, where you put the light bulb back in the holder and put all the batteries back in the holder. And we're going to do basically 3 experiments, and each person will have the toys for one of these activities. So whoever finishes first, go ahead and reassemble things and get that ready. And again, this activity will start by you pretty much reading your idea about the question that's posed on basically which direction will electricity flow when you connect it up as shown. We do not have a switch. You'll just be using the alligator clips as a switch. So your switch will essentially be, okay, this is off, this is on. I'll go ahead and hook up a light bulb. So I've got a wire coming from each end of the battery pack. This wire that's connected is the positive, coming from the positive end. No, sorry, it's not. Coming from the negative end. So this is the one that goes to the positive end of the batteries. And so this is off, this is on. Off, on. So you get the idea? We're just using the alligator clip as the switch. assemble the batteries in the holder and the light bulbs back in the holders. And since we've got two sets to your group, you could have maybe two people playing around with it. But I'd still like the four of you to do discussion.
One of our people was.
There are four.
Yeah, she is right there.
Yeah.
Yeah, she was sitting there. I'm not sure where she is now.
Well, she left her pen, so.
Okay, you're back. Yeah, let us know when you're done with section one.
The first question?
I guess my thoughts on
Section, you tell me section eight.
negative and positive.
Are you able to find or build that demo with the light bulbs?
I'm still working on it. It'll be done for Monday though.
I could put positive for second, but I think this is kind
I was
of
interested
like
in
counterclockwise.
With how we arranged the, like, I set it on top of the positive.
But I
it's
guess
still
we'll find out when we run out of
technically positive, just kind of ground and the light bulb instead of. So it's all
Okay,
the
so
same as far as I can remember.
basically, it's. So, what's everybody's thoughts on that?
I thought negative and positive.
That was my thought as well, but we also had some, let's say it was positive, negative, but it- okay, so we, so my reasoning for going negative to positive was that we agreed, it was mentioned in class that the electrons do the movement. And so if the negative side really does have a negative charge, that means that all of the negative electrons are going down the wire, being attracted to the positive charge and repelled from the concentrated negative charge.
That's why I asked, yeah, because both from the part of the atom,
That's not really draining in there.
it's like going hot, cold, you know, cold, negative, hot. Would you guys agree, or
Yeah.
do you have a better idea?
No, that makes sense after thinking about it, yeah.
You ever made like a saltwater? Package?
It's a hand
And then
actually.
why would it go from
Pretty
negative?
cool, but,
No,
so you get some penny
the arrows,
and
when it talks
what's another
about,
type of metal? I can't remember which one I used.
Because,
But I'll see that soon.
It is said that a picture can say 1,000 words.
It's not very-
So if you use the diagrams on the second page of this particular activity to basically draw arrows for the different group activities, that might be sufficient rather than trying to write a sentence of what each person thinks.
so this part is
I
the.
did
arrow,
just recently.
I
It was
put
like battery.
the longer
You
arrow
have
next
two
to the
different
negative.
metals in that conductive solution. And you run it current. So it's just kind of like a little big metal for
So you think you wouldn't get
A little
smaller,
higher.
the arrows would get
And
smaller after.
this tanker comes down from like
You think the switch
300 or
would slow it
400
down?
yards and he's like,
No, not really.
No, that's what you
It's
think.
basic.
well,
It's just a
it's
simple
stuff,
why.
and he's like,
That's like, I don't know if that just explains us.
So which way did you have your arrows? We had to
There's no
actually
way
have
his
like the
couch
bigger
is
and
Victoria.
And then you
So
have
did
your
either
arrows,
of you guys have
going
any
clockwise or
interest
counterclockwise?
exactly tells me where to put it.
Okay, folks, I've heard a couple people talk about how to represent more electricity or less electricity. On your diagrams, if you think there's more electricity in one part of the circuit compared to another, draw a longer arrow or a fatter arrow. And in places where you think there's less electricity, draw either a shorter arrow or a skinnier arrow.
So did you rehab it?
Yeah.
So-
You made, yeah, it's part of the electrolyzed out.
More or less electricity. So like if there's a charge, like they have to add like power to so when you connect it, the ones that are gonna be coming back.
Well, that was everybody's needs to.
Positive.
The only experiment that's
I'm sure it's still.
Because the object I wanted to coat with now felt the most, I'm pretty sure I have that positive. Because, yeah, the nickel ion.
Okay, folks, we have limited time. I'd like you to move on to experimentation as soon as possible.
And I mean,
Positive.
Ethan Anderson. Okay, experimentation.
You cruise?
Is anybody else gonna want to do this?
Well, so you have your two metals.
You got two setups for this group, so you can do that.
Copper and
That is positive, right?
solution. So
Yes.
the nickel was pulled out from this cathode, and then reacted with the vinegar to become nickel.
These battery packs should be set up so that the red wire coming out of the pack is positive,
It breaks
and the
apart from water.
black wire coming out is a
And the
negative.
nickel ions are attracted to the positive. Or,
So how do
you know,
we do this experiment? Tell us
and then
why.
they'll deposit onto the surface.
So
of it.
if this
So you keep the nickel,
Make observations and see if there's something you can observe and apply that.
but then
I
it
mean,
deposits
okay,
it
so
on
we
the
can-
so that fluid cell can sort of- Okay. But yeah, you dissolve your nickel into and then deposit it out of solution onto the copper. So whatever your positive is.
It's crazy that you can make hydrochloric acid. Salt, vinegar. I don't know if
Yeah. They could be fairly, especially because most vinegar is about 5%.
How can we try and figure out which
nonetheless,
way to go?
it's a strong acid. It's just-
For the big question for this activity, if you think that one of your observations tells you which direction the electricity is going, please make a mention of that. If anything from your experiment, it tells you whether or not you have more electricity before the bulb or after the bulb or some other place, state that. And also, if you don't think you can come to any conclusion on those questions, state that as well.
Mhm.
So that's what I'm looking for.
Yeah, I guess I also made some chlorine gas with it. So I put a little bit of salt in there to just allow the electricity to conduct better. So that technically also pull it
So
out.
basically,
But
just
since
with
it's
the polarization of
not too bad. I mean, chlorine gas is poisonous itself, but I didn't produce anywhere near enough.
It lights up, but I think there's a difference.
This basically makes chlorinated apple with vinegar. Yeah, well, nickel acetate is more poisonous in higher concentrations.
Do you have like another light bulb we could attach to?
Yeah,
Yeah, the food actually turns green.
Can we agree that it's either we have it,
I actually have some
the
pictures.
long wire on the red? Hey, you have the negative? Possibly. Should I do it one more time?
Yeah, I don't think Riley can see 100%.
So, and we have a second battery pack, so you guys can try this too. So this is it with,
Yeah, there's more batteries it is.
and.
But I've watched them do this twice and I don't see a difference on this.
You guys don't think so?
And then it pulls the nickel.
Now, if you stare at it long enough.
I know.
Vinegar.
I see spots.
Yeah, maybe it's just the highlights. Okay, so.
Okay, I'd like to move on from this as soon as possible. And remember, basically have somebody else play with the toys for the second, for the next experiment, the third one, E13. No, sorry, E14.
I think if we tried to, see that, the two light bulbs, maybe we can see a different number, I guess, but I think with just sound, we can't.
So for this next experiment, we're going to have two light bulbs. So maybe you can make some more conclusions. But was anybody able to make any conclusion whatsoever on the direction of the electricity? Or how much electricity we had at one point of the circuit versus another? Does anyone want to comment volunteer to at least comment on what you observed? Any volunteers? Mr. Crossgrove?
Yeah, our group basically decided that we have no idea what's going on off of what we have.
By no idea meaning which direction the electricity is going or where the electricity might be stronger or weaker.
Both.
Okay, so you did conclude that the observations don't tell you anything on those two questions.
Exactly.
So that is something. That is a valid, conclusion to an experiment. Did anyone come up with anything different? I think that's pretty telling. So I'd like you to move on to the next activity, if you will. But as a comment, while you're maybe finishing up writing, does anybody know who Jay Leno is? He was a late night talk show. One of the things that he did that I really liked the best is he would often show up to a graduation ceremony. And he went to Harvard and he attended the graduation ceremony of their engineering school. So he's talking to engineering graduates, people walking out with a diploma of a bachelor's degree or a master's or even a PhD in engineering. And he approached over 100 of these graduates with the question you had in the very first activity. Can you make a light bulb light with just a single wire, a battery, and a bulb? 2/3 of the students were not able to do this. And these are engineering students after 4 years of engineering school, where they've all had classes in electricity and circuits, and of course, 3 semesters of physics. So don't think of that as being an obvious question. And most of them, however, when playing with it, about, again, close to 2/3 of those that actually played with the wire were eventually able to make it light, but there are many that said it was simply impossible. You couldn't do it, you'd have to have 2 wires. I just thought I'd share that with you. So don't think these questions are too basic.
Okay, so this is exactly what I said we would need. We have 2 light bulbs, so we can compare the prices.
So be sure to switch the toys so somebody else gets to play with them
Yeah.
in your group. And in fact, since we're running short on time, I'd almost say try to do the experiment with 2 light bulbs and then 3 light bulbs almost at the same time. So have your discussion, quickly switch toys so that everybody at least gets to play for at least a little bit. But we only have about 10 minutes left to do these last 2 activities.
Well, he said we'll want to try this with 3 at some point. Okay, so we're going to do.
And then the one that's on the returning side.
Yeah, before you actually hook up your circuit with the 2 light bulbs, do write down your thoughts and have discussion. I want you to do that before you set up the circuits. But you can have your discussion now for what would happen with 3 light bulbs as well. Do you have 2 light bulbs set up over there? Is that 2 light bulbs I see?
Yeah.
Dave? Yeah, that's not right. You've got either a bad light bulb or a short going on. Braden, could you grab him another? Yeah, switch out the one that wasn't lit. Because if you shorted out a bulb, you would get what you see. If things were working correctly, you would not have seen what you just did. Okay. Let's see, Braden. Yeah, could you troubleshoot that?
Yeah.
Please.
Okay, that's kind of a good goal.
Reed, that tells me that they had a short someplace, so the electricity wasn't actually going through the light bulb, it was going straight through the base somehow.
Yeah,
It all sounds like they're the same brightness again. An even distribution.
I do hope you've had some discussion on what to expect before you do that.
Oh, yeah.
Okay.
Oh, yeah.
And it's those same things that evolve through this. Let's see. So that voltage goes in.
Yeah, it looks like they came on simultaneously.
Figure out- I can't remember what, but it's basically the same thing as electricity. It's from more power.
I just drew the diagram, I think you gave us some good, and they only about like, they only light up at the same time, the brightest, and then it would go dimmer
I
and
remember
dimmer,
printing that line. It's-
just like,
I'm not sure you're on the same page.
well, he said two and three together, so I was showing you three. So here's
Well,
the-
I'm in car.
The brighter, the smaller. And the
So, yeah, we still don't know.
Yeah.
Basically.
Yeah.
Shorter. So on.
Yeah.
Did anybody bring you write anything different?
That was your thinking too.
Okay.
Okay, Colton, we got a bad wire.
So let's, I guess, do the experiment then.
Okay,
So-
our
Put like a little bit
expectations
bad.
are, yes. No idea.
Yeah, if you see something funky going on, it could be that you got a short of the base or you got a broken wire. That's what we just had over here in the back. We had a broken wire.
Here, do you need another wire? I have extra.
Now what we're going to do is you're going to turn these in. Again, make sure that your name and your groups, your partners' names are on these. Frankly, your first name would just be fine. We don't have much. In fact, we don't have duplication of first names much, except for a couple people, and I think I can keep track. And then I'll return these to on Monday, so you have them for the Monday activity. But I do want the weekend to look them over.
Okay, one's lit, but
Wait,
one
did
is
you try a different
The
line?
negative one is, oh, you're right. So the negative one is lit. But the one closer to the negative one is brighter than the positive. But they're both way different. So I guess one thing we also forgot to address in our discussion was how bright did we think they were going to be compared to the one with just one light bulb?
And I,
Oh, hold on there.
yeah.
That's what I thought too.
I
Okay, so.
One.
Nope.
Yeah, can you see it clearly?
I can't.
I think I'm gonna stick with.
Just the top.
So in the end, one did it ended up being darker and two was way darker.
Brayden, we've got a voltage problem. This has a different voltage than the other bolts in their set. So let's,
This
Do they
is
have
something
bulbs that
else
look
that
check
I
it out.
just want to clarification on.
just,
This battery here, it has the negative end coming out with this black wire.
Yes,
they were
the
getting
black
something
wire
funky
is,
going on when they had that voltage.
black wire is the negative one, you're right.
So it's actually opposite.
Yeah,
You see what I'm saying?
yeah, you're right.
You guys all do?
Well, I just want to make sure I'm reading this right. This is the negative
Let's
side
switch
of the
the-
black.
Hold on a second, there's something I want to try to make sure we don't have a faulty bulb. Let's switch the order of these. What if we?
It is, but we
In
were
fact, if we
wondering
can just take
if
those ceramic ones out.
we assumed
for this
that the
and let me know if we
negative
need to order
charge
more.
side would have
Should have
lighter,
enough fixes.
brighter. But it's not appearing that.
So now we're switching the order to make sure that it wasn't just a faulty light bulb.
Okay, I'd like to pause a moment and have a little discussion. Keep writing. But-
confirmation, we have a faulty.
It looked like in all cases, we actually got the things working, that there was no difference in the light bulb's brightness. Say when you have 3, they were all the same brightness, but a bit dimmer than if you had either 1 or 2 bulbs. And with 2 bulbs, they were the same brightness, but they were brighter than when we had 3 bulbs and less bright when we just had 1 bulb. Does that make sense? That's an observation I saw. Is there anything any conclusion we could draw from this with regards to the direction of the electricity and how much electricity is going at each point in the circuit? Anyone want to comment on that? Ma'am?
I'm guessing there must be the same amount of electricity going through it, no matter how many bulbs are connected. That's my guess. And then when you connect more bulbs, it's just distributed evenly
Okay.
between them.
That makes sense, ma'am. What's your name?
Shelby Reynolds.
Okay. Does anyone want to add to that point? In that, in any given circuit, you've got the same amount of electricity everywhere, but do you have less electricity when you have 3 bulbs versus 1 bulb? Or 2 bulbs? Can we make that kind of comparison?
We have less brightness, if not less electricity.
Okay. And you can also think of energy. Is the combined brightness of 3 bulbs the same brightness or less than when we have 1 bulb? That's something to consider. But is there anything that you saw that indicates whether or not the current is going clockwise or counterclockwise? Sunwise or Widdershins? Or from positive to negative or negative to positive, anything like that. Those are the important questions.
I think that, in that regard, it was inconclusive.
Okay, be sure to make a note as to whether or not you can tell the direction. And also make a note on the relative amount of electricity in the circuit in different places based on this. Those are the important points. And once you do that, go ahead and turn in your work. In fact, probably it's after class. Go ahead and turn in what you have. And we'll continue this on Monday. Thank you for your attention. Just put your work on